industrial structure, software dependence versus engineer's role. For the last few decades, we have seen the revolution of this software dependency. Before 10 years, 15 years, we didn't have this mobile phones. Currently, we are unable to spend a minute without a mobile phone. So software is kind of thing which is very essential for today's lifestyle and for tomorrow's lifestyle. And the same is applicable in the field of industrial engineering also. Like I said, as a structural engineer in the field of structural engineering also, this software dependence has evolved in the last 15-20 years uh, as a useful tool. So start with the today's topic. These are the contents I'll be covering today. So let's start with very basic things. Structure. What is a structure? A structure is a system which carries the load, which transfers the load, which dissipates energy and makes the system stable. This term stable, maybe it is an engineering term, but if you just think of anything you see nearby you, where even a pen, pencil, everything, once you put it in the right space, you will find it will not move. Once it is not moving, it is stable. Once it starts moving, it is unstable. What is the function of a structure? A function of a structure is to transfer the load safely, carry the load safely. Not only it has to transfer the load, but it has to carry the loads also. Otherwise, if I am not carrying the load will not get transferred. So, function of a structure is to transfer the load, is to carry the load, and is to maintain the equilibrium of the structure. Now, when is a structure unsafe? There are different kinds of collapse or failure. Maybe in some cases we can say it when it comes as unserviceable, it also becomes useless to us. Say a room, it is not for living, so it is not useful for us for living. So that is unserviceable. And these are very basic structures we see in our daily lives. Like you see now, human skeleton, it is just a big example of structure which maintains loads, carries loads, and transfers the loads to the ground. Now you can see spider web. Spider web is a special kind of structure. Web designed by the spider is completely a tensile web, where every string of the web is in tension, not in compression. Now you can see in my last picture, if you see every structure, whether stable, unstable, everything moves. Moves means deflects, not moving entirely. It deflects to some extent. This in my previous slide I have said serviceable and unserviceable. So this unserviceable condition is when the structure is deflecting to a large, it becomes unserviceable. It seems unsafe to our psychology. Coming to the next point, forces. What is a force? A force, when applied to a body, it causes some deformation. In any type of deformation or movement, deflection, and of course it is based on the support condition of the structure. Type of forces loads. The type of forces loads we deal with in structural engineering are gravity loads. Those are permanent loads. Gravity loads are those, the self weight of every equipment, every structural member, or anything linked with the structure, that is constant, that will not be removed. The second thing is again a gravity load, that is live load. Say human presence. The human presence in a structure at a particular time is varying. At a particular time there can be a person, at a particular time there may not be a person. So that is called a live load. That is a short term load, short term gravity load. Now coming to the lateral forces. There are various types of lateral forces for say wind, seismic, and wind, seismic, and for gravity loads also there are some other loads like snow loads, dust loads. Now, self-straining forces. This is a special type of force. This is not a lateral force, not a gravity force. This is caused mainly by the temperature loads. We can see in many places we have extreme weather conditions. In those weather conditions, the structure there is a force generated in the structural system that is purely self-straining. Why self-straining? Because of the temperature differences, the structure itself experiences a strain within itself, and it transmits the force to the base. But the ultimate force summation of the forces should be zero. That's why it is called a self-straining force. And next is dynamic forces. Dynamic forces is caused by wind, seismic, anything it can be. It is mainly for higher structures with a very good height, where these dynamic forces come into effect. It can be because of the wind. It can be because of the seismic. Now, and it also depends on the location of the structure. If the structure is located in a seismic prone zone or a zone where wind forces are very frequent and very high in nature, wind velocity is very high, in those cases we see these dynamic forces come into an effect. This dynamic forces causes the structure oscillating, the movement of the structure, like a vibration. It makes the structure vibrate. In my previous slide, as I said, these are type of forces, loads. Now we'll be coming to the forces. Now we'll be covering these forces. These are basically caused by the forces I have mentioned in my previous slide. These are structural forces, axial forces. These are forces basically carried by the structural elements. Axial forces acting on one axis directly on a point of surface, and it acts along the axis of the member, like you see in the picture. Second is moment, bending moment. It basically acts about an axis at a certain distance from the point of application of the load. Like you see here, if the force F is applied at one end and the length of the blue member is d, then the moment generated on the other end will be F into d. Now, structural framing. As I've mentioned, what is a structure? It is a system. Basically, in a structural system, there are multiple frames. A structural system consists of many frames, and a structural frame consists of many structural elements such as beam, column, bracing, foundation, etc. What are the types of structural framing? Breast frame, moment frame, trusses. So when I say a structural system, it may consist of breast frame, it may consist of moment frame, it may consist of trusses. Also, it can be a combination of all the three or any of the three. End condition. Now, end condition, if it is a a steel structure, then and supported on a concrete foundation, then there has to be an interface between the steel and the concrete. That is what we call pinned end condition, that is pinned or fixed. If it is a purely concrete building, in that case also there is an end condition. If the foundation is rested on the soil, based on the support condition of the foundation, we call it fixed. It is supported, and it can transfer the forces, the moments, everything. A pinned condition support cannot transfer any kind of moment. It can only transfer forces, not moments. And a fixed condition support can transfer any kind of forces as well as moment. Now connections. This is the most sensitive part of a structure. When a structure is a steel structure, there will be steel to steel joints. When it is a concrete structure, there will be a steel, concrete to concrete joint. How do we connect it? There will be a horizontal member, there will be a vertical member, so there will be a diagonal member. So based on the orientation of the members and the material of the members, we decide this connection. This is the most critical part of the structure, and it tends that this part of the structure is very sensitive and it can fail if not given a true care. Here you can see the pictures of various frames, trusses. The first one is a moment frame, the second one is a brace frame, third one is a diaphragm. Diaphragm. What is a diaphragm? A diaphragm is a frame where there is no bracing, but there is a monolithic and high stiffness material that is connected between the columns and beams, which can transfer the axial loads, the horizontal loads or the lateral loads. So there is no need of bracing, but the force will get transferred through the wall or diaphragm, as you can see in the picture. We have gone through the structural framing concept based on the structural arrangement and elements. Now we will be covering based on the forces. A structural framing is a determinate frame or indeterminate frame or unstable frame based on the equilibrium equation and based on the unknowns we have some known forces, we have some unknown forces, and based on that we need to solve the equation for equilibrium. And to solve the equation of equilibrium, we need, if we have the number of known equal to the number of equations, then we can solve it. So it is a determinate structure. In case we have lesser equations, it is an indeterminate structure. And in case we have more equations, it will be an unstable system. This is the mathematical interpretation of a structural framing. Materials. What does a structure consist of? basic the basic skeleton of a structure consists of many materials. It can be steel, concrete, RCC, nowadays wood. Many other materials are also being used. For industrial structures, we use mainly steel and concrete. Now grades. What is a grade? A grade is the inherent property of the structural members that are being used. A grade basically depends on the material grade of the material is a material property, and it depends on the usage requirement of the project. Basically the yield strength, the tensile strength, the strength of the member comes from the grades. How do we decide which grade to choose, which material to choose? It is different from project to project. It is dependent on the time involved for the project to get completed. It depends on the cost involved in the project. It depends on the fire hazards. For some structures, there are some in oil and gas projects. You will see there are structures where there is high probability of this fire occurrence. So in those cases, if there is blast, if there is fire, the steel can melt. That's why there are many equations causing this material selection. Now composite material. Many a times we can see that for mainly for fire hazardous zones, we use composite materials. We use steel because it saves time for construction, and but it is not safe for fire hazardous zones. So that's why we use steel with a concrete fireproofing. That's why I'm calling it a composite material. Also, it depends on the site locations, site weather conditions. Now design of structure. To design a structure, we basically need to go through the codes. If it is an Indian project, we have to go through the Indian code. We have to go through the zonal requirements. What is the wind velocity there? What is the seismic parameters there? We need to go through these things. We need to go through the client specifications, where you will find the requirement of the project, the requirement of the building, why the building is required. Based on that, you will be able to decide the loads. And regarding the structure, you will see that many clients define each and every structure with an importance factor. If it is not defined by the client, then it will be decided by the codes. In codes, we get different kind of groups for this importance of structure. So based on these requirements, we design the structure. Now, how do we design the structure? There, just in a layman language, if we say, there are basically two things. One is the strength, second is the serviceability. What is strength? The structure has to carry the load and transfer the load to the ground, and it should not fail. That is the prime objective of a structure, and that's why design for a strength condition is very important. Now, the second condition is serviceability. What is the serviceability? If we just make a structure, say a room, we make a room with a height of maybe 1.5 meter. Nobody will be able to move freely within the room, because generally we have a height of more or less 1.6 meter to 1.8, 1.9 meter, the normal height of our. So we will not be in a 1.5 meter roof, we will not be moved freely. So that is not a serviceable condition. It should be in our comfort. If the structure gives us comfort, that is a serviceable condition. One more thing, if you go to a high rise building and go to the roof, and if you feel like that it is moving to and fro and it is moving very fast, that means you are becoming conscious about the movement of the structure, and you are psychologically not at all comfortable at at that situation. So that's what we call an unserviceable condition. So serviceability is also a very important aspect of the design. Generally, for design of structures, we determine the deflection of a structure from the serviceability limits. There are safety factors also for some important structures. We have greater safety factors for different codes. We have different safety factors. And the third, last thing is detailing. This is one of the most important thing. As a structural engineer, when you design a structure and it becomes safe, it is okay for you. There is no issue. But once you start detailing it, it will be like, sometimes you will see your design is not at all feasible for detailing. It will not be constructible. So that's where detailing comes to action. In my previous slides, I was mentioning for this connections, for this connections, steel to steel, steel to concrete material. So this, for this connection, this detailing part is very important. Detailing, to detail a connection, to make it feasible, to make it constructible, is a whole thing that we need to keep in mind. Failure of a structure can fail in various ways. It can collapse, it can fail due to environmental loads,